Here we go, trigonometry for our quiz review video from the end of our chapter. Given triangle ABC, where C is the right angle, find angle B and sides A and B. We're going to do this with inverse trigonometric functions. First thing we're going to do is just use the triangle interior angle sum theorem to find that missing angle, and that is just subtracting from 180. So 180 minus 90 minus 29.4 is going to give us angle of 60.6. So our missing angle, 60.6. Angle B, 60.6 degrees. So from here, given that we know the hypotenuse, we can easily find the adjacent side and the opposite side. So let's just set up a sine function. The sine of 29.4 is equal to the opposite side over the hypotenuse. All we have to do here is cross multiply and solve. So here we go. So 32 times, and I'm going to check first and be sure that I am in degree mode. I am not in degree mode. I am in the default mode on the calculator, which is radian mode. So click over to degree mode because we are entering in degrees. That's very important. So let's try that again. 32 times sine 29.4. That gives us A is 15.7. So side A, 15.7. And let's think for just a minute. If our hypotenuse is 32.6 and side A is across from the smallest angle, angle A, little a better be smaller than C and B. We will check that with B in just a moment. So to find B, let's just use the cosine function. So the cosine of 29.4 is equal to adjacent over hypotenuse. So cross multiply again, and we will be able to solve for B. So 32 times the cosine of 29.4. 27.9, and I'm rounding to the nearest tenth unless otherwise notated. So there we go. We have solved the triangle. Let's do it again. This time we've got, again, angle C is the right angle, and all we know are the hypotenuse and side BC. So we can use the Pythagorean Theorem in order to find the missing side, which is going to be little b right down there. A squared plus b squared equals c squared. So 17.5 squared plus b squared equals 22 squared. Let's solve for b squared here. So 22 squared minus 17.5 squared leaves 177.75, which we will then, if it's b squared, will be taking the square root of. So let's take the square root of that, and we get 13.3. So B is 13.33. All right, so now let's find angle A. This is going to justify an inverse trigonometric function here. So the sine of angle A is equal to the opposite side over the hypotenuse. So if we need to find an angle, we need to undo the sine function. So let's take the sine inverse of both sides. The sine inverse undoes the sine, and that leaves us angle A. This is what's going into our calculator. Again, be sure you're in degree mode. So we are going to have sine inverse, and I'm going to utilize my fraction. Of course, the fraction is the second alpha f1. So from here, so this will be 17.5 on the top, on the bottom is 22, close the parentheses. We get angle A is 52.7 degrees. 52.7 degrees. Let's do it again, and let's find angle B this time. Angle B, and if we want to find angle B, let's consider angle B as our angle in question. So side A will be our adjacent side. So this time we can use the cosine function, cosine inverse. So the cosine of angle B is equal to the adjacent side over the hypotenuse. So once again, let's take the cosine inverse of both sides. Cosine inverse of cosine B equals the cosine inverse of 17.5 over 22. The cosine inverse undoes the cosine. I'm writing that on purpose so you can see that those are indeed inverse functions and they are undoing each other. And it leaves us with angle B, which is what we're after. So let's use our cosine inverse function, cosine inverse. Once again, to access the fraction, hit alpha F1 on the 84 plus calculators. And that's going to be 17.5 on the top, 22 on the bottom, close the parentheses, and we get angle B is 37.3 degrees. Now, let's go back, let's look at all of it, and let's make sure that our answers make sense. So here we go. We know that 22 is the longest side because it's across from the right angle. It's the hypotenuse. So side A is larger than side B. Therefore, angle A must be the biggest of the acute angles. Angle A is 52.7. Angle B is 37.3. So check, check. Our answers make sense. This next page has us evaluating using inverse functions. So we have the cosine inverse of -1/2. If you recall from our notes, the cosine inverse only exists in quadrants 1 and 2, from 0 to pi. So where between 0 and pi is the cosine negative? Well, obviously not in quadrant 1, since everything is positive in quadrant 1. Must be in quadrant 2. So where is the cosine -1/2? Well, visualize the cosine at 2 pi over 3. So this rotation is 2 pi over 3. What are the coordinates here? They are back 1/2 up √3 over 2. Therefore, the cosine inverse of -1/2 is 2 pi over 3. Let's keep going. The next one, consider order of operations, always in effect. We look inside the grouping symbols. Inside the grouping symbols, we have the sign of 3 pi over 2. So let's evaluate the sign at 3 pi over 2. 3 pi over 2 is all the way at the bottom of the unit circle. And the sign is going to be the y-coordinate. So this is over 0, down 1. 0, -1. So the sign of 3 pi over 2 is -1. And now we are going to do the sign inverse. So yes, when we took the sign inverse of both sides on the previous problems, we were just able to cancel those. But here, the answer is not 3 pi over 2 because the inverse sign only exists down to -pi over 2, which is a hint, and up to +pi over 2. The inverse sign only exists on the right-hand side of the y-axis. Therefore, this is not in the interval that is -pi over 2 to +pi over 2. But what is coterminal with 3 pi over 2. 3 pi over 2 is coterminal with negative pi over 2, and at negative pi over 2 is where we find the coordinates 0, negative 1. So the inverse sign of negative 1 is negative pi over 2. Two last problems. Evaluate the exact answers. These are the ones we were doing last in class. These are the ones that we need to draw a diagram. We're going to be drawing a diagram in order to prove our answers. These are also the questions where you're going to initiate a whole new variable. So I am going to let big B represent everything that's inside of those parentheses. So let B equal cosine inverse of 5 over 12. So if B equals cosine inverse of 5 over 12, then cosine B equals 5 over 12. This represents a triangle. So what we need to do is we need to draw this triangle. It's just a right triangle. It doesn't have to be beautiful or perfect. And let's put B right down there. So cosine B is cosine, by definition, is adjacent over hypotenuse. So this is adjacent, this is hypotenuse. Let's use the Pythagorean Theorem in order to find the missing side, which will be the opposite here. So 12 squared minus 5 squared equals, we'll just call it a squared over there. So that is 144 minus 25. 144 minus 25, I'll check it on the calculator since I'm a little sleepy. That is 119. So 119 equals a squared, square root. I don't think 119 has any factors. I believe it's a prime number. Let's be sure it's not divisible by 7. Divided by 7. Oh, it is. It's 7 times 17. What do you know? But it's a product of prime numbers. So even though 119 is 7 times 17, still not going to simplify. So we're just going to leave it 119. So if our opposite side is the square root of 119, can I go forth and then find the cotangent of B? Because remember, I let all of that be equal to B. So cotangent B. So tangent is opposite over adjacent. Cotangent is adjacent over opposite. So 5 over root 119. We're going to be thorough here. We're going to rationalize our denominator. So we're going to have to multiply by root 119. We get a final answer. The exact evaluation of 5 square root 119 over 119. That is the answer. Let's do it again for the last problem in the video. So, once again, we're going to introduce a variable. So we are going to let all of this quantity be known as z. All of it is going to be known as z. Let z equal sine inverse of 1/5. If z equals sine inverse of 1/5, then let's let sine z equal 1/5. And once we see that sine z is equal to 1/5, this is going to translate to a triangle. So once again, draw a little right triangle, put z right down there, here or at the top, it doesn't matter. Sine is opposite over hypotenuse. Let's use Pythagorean Theorem and let's find the missing side. So that's going to be 5 squared minus 1 squared equals a squared. So 25 minus 1 is 24 equals a squared. Square root. Please simplify the radical. The square root of 24 is 2 root 6. So our missing side is 2 root 6. Let's finish off this problem by finding the secant of z. Remember, all of that was replaced with z. So secant z. Secant is the reciprocal of the cosine, and the cosine is adjacent over hypotenuse. So we need hypotenuse over adjacent. Secant, hypotenuse over adjacent. And once again, we're going to rationalize our denominator by multiplying by root 6 over root 6, which gives us 5 root 6 over 2 root 36. Root 36 is 6, so 5 root 6 all over 12 is our most simplified answer. And that is our quiz review.